podcast in this unit, and it simply is going to be kind of explaining what LeChatelier's principle is like. And what you need to understand is LeChatelier's principle, just in general, is when a system at equilibrium is placed under a stress, the system will undergo a change in such a way as to relieve that stress. So if you're under stress, hopefully you find some way to relieve that stress. It might be going and get a cup of coffee, it might be going and get a golf ball and hitting it really hard, whatever you would do to relieve stress. Okay? Well, reactions are the same way. If we force a stress on them, they're going to change to relieve that stress. Alright? So we're going to use this equation as an example. And it's simply 2 SO2s plus O2 are in equilibrium with 2 SO3s. And what I'm going to tell you is this reaction is an exothermic reaction. So it has a negative delta H. What I would be on the habit of for these problems, if something is exothermic, or you say it's negative delta H, I would actually write the word heat on the product side. How come? Because it is producing heat. It's releasing heat. If something is endothermic, I would be in the habit of writing heat on the reactant side. Okay? So there's several ways we can introduce a stress. Alright, so we're going to define some stresses down here. Stresses can be additional product or reactant. Okay? Stress can be heat. And really, those are the only two things that we're going to talk about in general chemistry. So let's say, as this reaction, let's say it's at equilibrium, and I decide, you know what, I'm going to add some more oxygen to this thing. Okay? So if we look at our balanced equation, we're going to find oxygen here on the reactant side. Okay? So if I add more oxygen, this is going to, the reaction is going to try to shift itself to get rid of the additional oxygen I'm adding. So because oxygen is a reactant, alright, it's going to want to get rid of that reactant. So what's going to happen is the reaction is going to shift to the right, and we're going to end up making more SO3. Alright? If we add additional SO3. So another complete example. Right? So I'm going to, over here I increased my oxygen, over here I increased my SO3. Alright? So if we look, SO3 is a product, okay? But I'm putting more SO3 in. So the reaction is going to want to take away some of that SO3 because I'm adding extra to it. It's going to want to relieve that stress. So in order to get rid of that stress, my reaction is going to have to go the opposite way, alright? So it's going to go back to the left, and I'm going to make some more SO2 and O2, alright? The reverse of this is also true. Let's say I take away, alright, some SO2 from my equation. Alright, so I'm able to extract that. It's a gas, and I can pull that SO2 out. Because SO2 is a reactant, if I remove it, the reaction is going to want to shift to replace what I'm removing. So if I'm removing a reactant, the equilibrium is actually going to shift back to the left as well, because it wants to replace the reactant that I'm removing. Alright? So again, if we add stuff, it's going to shift away from the side we're adding. If we take stuff away, it's going to shift to that side to replace what we're taking away. The other thing we're going to look at is heat. Alright? And heat works the same way as product reactant. In this particular reaction, let's say I increased the heat. Okay? And I just want to know, is this reaction going to go to the left or to the right? Is it going to become forward favored, or is it going to become reverse favored? So because heat is a product, alright, and I am adding more heat, it is going to shift to the left or towards the reactant side. Same idea as adding products or reactants. And if I decrease the heat, alright, so if I put this in like an ice bath, what's going to happen, if I decrease this, decrease the heat, it's like I'm taking the heat away from this side, so I'm removing this heat. So if I'm removing it, the reaction is going to shift to make more heat to make up for what I'm removing, so it's going to shift to the right or be product favored. So that's LeChatelier's principle. Last thing, catalysts do not affect equilibrium. Okay? So they don't make a reaction go left or right, they just make the reaction go faster. How do they do that? By lowering the activation energy. So again, the only two stresses I want you to know about is addition or subtraction of products and reactants, and then the addition or subtraction of heat. And the main thing for heat is if it's exothermic means heat is a product, and if it's endothermic, heat is a reactant. And then if you know it's a reactant or a product, you solve it the same way as you would additional product or reactant.